Good morning to our dear panelists. Praised be Jesus and Mary. This morning, we will be presenting our research concept proposal entitled Univariate Time Series Forecasting for Index and Non-Index Crime Prediction in Misamis Oriental, Philippines. Crimes occur all around the world. According to the Global Initiative Civil Society Organization, the prevalence of these unlawful acts, both in richer and poorer countries, is one of the underlying drivers of many geopolitical challenges, including conflict, political instability, and forced migration. It makes a huge impact on our society, leading to losses and damages that may even last for a lifetime. It causes fear of crime, financial loss, physical injury, increased use of victim and health services, slow economic growth, and loss of life, to name a few. Up until now, police agencies employ traditional policing strategies to solve these crime problems. However, due to the problems associated with such strategies, alternative ways have been used, including team policing, smart policing, and predictive policing. Predictive policing, which is also known as crime forecasting, is the process of using analytical techniques in foreseeing crimes before they happen. This technique to predict crimes is crucial since it may help save a victim's life, mitigate lifetime-altering anxiety, and avoid damage to private property. According to the study of Shash et al., it might even be applied to anticipate potential terrorist offenses and activities. In other words, the development of technology has led law enforcement agencies to leverage crime forecasting in solving and preventing the ongoing issue of crimes.
In the Philippines, crimes are still a major concern. This is an issue that impacts not just the safety and well-being of the population, but also has much bigger implications. The 2023 Global Organized Crime Index presents a dismal assessment on the state of criminality in the Philippines. The country ranks 25th out of 193 countries, 10th out of 46 countries in Asia, and 4th out of 11 countries in Southeast Asia in terms of criminality, with a score of 6.63, indicating that the country has a concerning level of crime incidents. Crime rates can vary substantially within a country, revealing insight on the specific difficulties that local communities face. Based on the monthly report of Statistical Research Department, as of January 2023, Region 10 ranks 8th in the highest crime rate in the Philippines. The country's ranking indicates an alarming trend, showing a high amount of criminal activity in the region. To put this in context, Region 10 has a staggering 1,119 crime incidents per month. This alarming number of crime incidents in the region suggests a need for preventive strategies such as crime forecasting to allow law enforcement agencies and civilians to intelligently allocate law enforcement resources and take preventive measures respectively.
The prime objective of this study is to build a time series model to predict index and non-index crimes in Misamis Oriental, Philippines using autoregressive integrated moving average. And in order to attain our main objective, these are the specific objectives we aim to achieve.
First, we will conduct augmented decay Fuller test to verify the stationary of the time series data. This verification is essential because maintaining stationary is fundamental in the time series analysis. It ensures that the statistical properties, including mean and variance, remain relatively constant over time, which is critical for accurate modeling and reliable forecasting. If our time series is found to be non-stationary, we will implement differencing. Differencing involves the computing differences between consecutive data points to make the series stationary. This technique removes terms and ensures the statistical properties of the data remain constant over time. Next, we will plot the correlational and autocorrelation chart. These charts are essential in the time series analysis, as they help identify a relationship between variables and detect time-dependent patterns, aiding accurate modeling and forecasting. Our next step involves crafting an ARIMA or seasonal ARIMA model. This process is rooted in a careful analysis of data. We will pinpoint the right parameters for the autoregressive and moving average components by studying the data's unique characteristics and patterns. This ensures our model is a perfect fit for the dataset, making it a robust tool for forecasting. Then we'll verify the model and run tests to ensure it is accurate and dependable. This confirmation step guarantees that the model accurately represents the data and can provide reliable predictions. It's resembling quality assurance, helping us identify and rectify any issues, ultimately enhancing the model's forecasting performance. Lastly, we will then forecast index and non-index crimes and evaluate their predictability by considering both the occurrence and trends of these specific categories of crimes.
With limited resources, predictive models enable law enforcers to be proactive in their approach to preventing and dealing with crimes. Law enforcers can predict when crimes are likely to occur, with the aid of forecasts and data-driven insights, enabling them to take preventive measures and strategically manage resources. In dealing crimes, law enforcers focused a higher priority on proactive rather than reactive responses and not reliant on the availability of resources.
Predictive policing, or crime forecasting, will allow law enforcement agencies to intelligently allocate law enforcement resources such as funding. Law enforcement agencies receive budget allocations and funding for various purposes, including personal salaries, equipment purchase and maintenance, and community programs.
In conducting our study, we will begin by using the augmented decay Fuller test to determine whether our time series is stationary. If non-stationary is detected, we will apply differencing techniques to make the time series stationary. Then, we create correlational and autocorrelation charts to understand the relationships between variable and their time-dependent patterns. Following this, we will craft a customized ARIMA or seasonal ARIMA model carefully fitted to the unique characteristic of the data. We will then move on to the verifying the model's accuracy and reliability through comprehensive testing. In conducting our study, we will begin by using the augmented decay Fuller test to determine whether our time series is stationary. If non-stationary is detected, we will apply differencing techniques to make the time series stationary. Then, we create correlational and autocorrelation charts to understand the relationships between variable and their time-dependent patterns. Following this, we will craft a customized ARIMA or seasonal ARIMA model carefully fitted to the unique characteristic of the data. We will then move on to the verifying the model's accuracy and reliability through comprehensive testing.